of sparse matrix. What is the disadvantage of sparse matrix?
So might be the exhaustion of the memory.
Yes,
It's a loss of memory, sir.
wastage of memory. Okay,
Yes, sir.
and also processing time also increase. Okay, so if it is zero or any another number, we need to process. So processing time also increases, and also wastage of memory. So that's why we need to implement, or how do you represent any sparse matrix, okay, so that we can reduce the wastage of memory. Okay, so for any matrix, if most of the entries are zero, then it is called sparse matrix. So you can see in this diagram here maximum elements are zero. Okay, so this matrix maximum elements are zero. So this is a sparse matrix. Okay, so sparse matrix, either it is a square matrix or non-square matrix, no problem. Okay, so how many rows here? 1, 2, 3, 4, 5. How many column? 1, 2, 3, 4, 5, 6. Okay, so total number of element is 5 rows and 6 column. Total number of element
30.
30. Total number of element is 30. 5 rows and 6 column. Total number of element is 30. Among these 30 element, how many are non-zero element? 1, 2, 3, 4, 5, 6. You can see total number of element is 30, but out of 30 only 6 are non-zero element. Then that means it is a sparse matrix. So what is the disadvantage of sparse matrix? It is a wastage of memory. So how can we reduce the wastage of memory? Because 1 to 6 30 element. So if we store one integer element, integer data, 4 byte is required. So total how many bytes is required here? 30 into 4, total 120 bytes.
128.
120 bytes. Okay, 30 into 4, 120 bytes, plus total number of element is 1, 2, 3, 4, 5, 6. So 6 into 4, 24 bytes we have used. Total wastage of memory is 120 minus 24. Okay, 120 minus 24. So this is the wastage of memory, that many bytes. So how can we represent this sparse matrix? Okay, you can see here in the zeroth row. So when we represent a sparse matrix in 2D array row representation, so here there is always 3 columns. First column represent the rows, second column represent the columns, and third columns represent the values. Okay, so when you represent any sparse matrix, if you want to reduce the number of zeros, so 2D array row representation is there are always 3 column, but rows more than 1, maybe any number of rows, but column always 3. First column represent the number of rows, the second column is columns, third column is values. You can see where is 9? Where is the 9? Tell me.
So first
Where
row,
is 9?
column.
Zeroth row. Okay. Zeroth row
Yes, sir, zeroth row.
and column number
Fifth.
fourth. 1, 2, 0, 1, 2, 3,
Yes, sir.
4. So zeroth row, fourth column element is 9. So that's why zeroth row, fourth column element is 9. Where is 8? First row, first column element is I. So first row, first column element is 8. Similarly, zeroth row, zeroth column, third row, sorry, 0, 1, 2. 2 row, zeroth column element is 4. 2 row, 0th column element is 4. Okay. So total number of rows 1, 2, uh, 0, 1, 2, 3, 4. Total number of rows is 4, 5. 0, 1, 2, 3, 4. Okay. 0 is 1, 2, 1 is another, 2, 3, 4. So total 5 rows. Columns, how many columns? 1, 0, 1, 2, 4, 5. Okay. 0, 1, 1, 2, 3. Okay. Uh, 0, 1, 2, then it is fourth row.
So I will count all, no? In this.
Okay, yes, total number of columns.
Yes.
So 1, 2, 3, 4, 5, 6. The total number of column is 6, and total what are the values? 1, 2, 3, 4, 5, 6. Total number of values is 6. Okay. So what 2D array representation here? Total number of rows is 5, total number of columns is 6, and total number of values is 6. Okay. So there is 1, 2, 3, 4, 5, 5 rows, 1, 2, 3, 4, 5, 6, 6 column. So 5 rows, 6 column, and here you enter the values. Total number of value is 6. You can see, if you take another example,
Sir, this representation is only applicable to the sparse matrix.
only application for the fast matrix to reduce the wastage of memory. Okay. Suppose this is one sparse matrix. Most of the elements are 0. So what are the number of rows and what are the number of columns? First we have to, you can see. Okay. So total number of element, number of rows total, number of columns total.
6.
So total number of element. Okay. So to store one okay. So to store one integer, right? So 4 bytes is required. So the total 96 bytes is used to store this sparse matrix. Okay. Now, how do you reduce 96 from 96 bytes? So we have used only 1, 2, 3, 4, 5. So 5 into 4, 20 bytes we have used actually. But rest of the memory location stored 0. Okay.
Sir, how
So total,
so 6, no?
huh?
Sir, 6 elements are there, no?
1, 2, 3, 4, 5, 6. Yes. 6 means 24. Okay. 24 bytes we have used. So total number of bytes is used, you require 96 minus 24, 72. Okay. So 72 bytes is the wastage of memory. Okay. How do you reduce this? We always remember there is first column represent the row, second column represent the column number, and third column represent the values. So when we represent any sparse matrix into 2D array representation, row major order, then to suppose the number of rows is different, but total number of columns always 3. Number of rows are different, but total number of columns is 3. Okay. Now, where is 1? Tell me, where is this 1?
So 0th and
0th row,
column.
first column. So first you have to write the total number of rows. Total number of rows is 4 rows. Total number of column is
6.
6 column. And total number of values are
6.
6. Now, what is the first element? 0th row, second column, element is 1. Where is 3? This one, sorry, 2, then 2.
0th row,
row,
4th column.
fourth column, element is 2. Where is 3? First row,
1 0.
column, element is 3. What is 1? First row, fifth column element is 1. First row, fifth column element is 1. Where is 4? Second row, second column element is 4. Yes?
Sir, third row.
Which one? 7. Third
Is
row,
it fourth value?
third row, fourth column element is 7. Which one? 1. This
No,
row?
sir, four.
This one?
Two four.
Oh, here,
This
here.
one.
This one. Second row, second column, na? Column number is 2, na?
Yes, sir. Yes, sir. Yes, sir. Okay, sir.
Okay.
Okay.
2 rows, 2 column element is 4. What is 7? Third row, fourth column element is 7. Okay. So total number of bytes is, you can see 1, 2, 3, 4, 5, 6, 7. 7 into 1, 2, 3. 7 into 3, 21 element. So 21 into 4, 84 bytes. Previously we have used 96. Now 84. So if one matrix is given and question is coming like this, we have to convert this sparse matrix into 2D representation. Any doubt?
No, sir.
Okay. So now this sparse matrix is called triplet representation. This representation is called triplet representation. Why it is called triplet representation? Because number of columns always fixed. Okay, rows number, column and values, row, column and values. So that's why it is called triplet representation. The total number of columns always fixed, but row may varies. Okay, the total number of column always fixed. First column represent the row, second column represent the column, and third column represent the values. Okay. Now these sparse matrix are two type. Okay. So if it is a square matrix, then it is called triangular matrix. Okay. If any sparse matrix is square matrix, what is the meaning of square matrix? What is the meaning
Equal
of
number of rows and columns.
equal number of rows and column? So n square sparse matrix is called triangular matrix, and this triangular matrix also another two type: lower triangular and upper triangular. Okay, lower triangular and upper triangular. Lower triangular, a square matrix is called lower triangular if all the entries above the main diagonal are 0. Okay, above the entries, a square matrix is called lower triangular if all the entries above the main diagonal are 0, then which is called okay. Suppose The matrix is like this. It should be a square matrix. Okay. So you can see the upper triangular, upper portion is maximum 0 and lower portion the number of zeros is very less. Okay, this is the matrix, this one is the matrix. Okay, upper portion is maximum 0 and lower triangular is non-zero, then it is called lower triangular matrix. Okay, then it is called lower triangular matrix. Okay, you can see lower triangular matrix is most of the entries are 0, then we reduce, if we go from top to bottom, then number of zeros are less. That is called lower triangular matrix. And opposite is called upper triangular matrix. Okay, opposite is called upper triangular matrix. So this is lower triangular. This is lower triangular matrix. And what is upper triangular matrix? Okay. This is called upper triangular matrix. Okay. If we go down, the number of zeros increase. That is called upper triangular. You can see this portion, okay, is non-zero. But when it comes down, the number of zeros is increased. So this is nothing but upper triangular matrix. Is it clear to everyone? What is the lower triangular and upper triangular matrix? It is always n cross n matrix. First property. Second property, it should be the sparse matrix. What is the properties of sparse matrix? Most of the elements are 0. If any matrix contain most of the elements are 0, then it is called sparse matrix. So here this is a sparse matrix first. Now it is n square n matrix. Yes, n square n matrix. So number of rows and number of columns are same. Okay, number of rows and number of columns are same. And so that means it is a triangular matrix. Now we have to, it is a lower triangular matrix or upper triangular matrix. If lower triangular matrix means if we go down, the number of zeros is very less. Okay, upper row is number of zeros is very high, which is called lower triangular, and upper triangular, if it comes down, then number of zeros entries are increases. Then it is called upper triangular matrices. Okay. Now matrix where non-entries can only occur on the diagonal or on element immediately above or below, the diagonal is called tri-diagonal matrix. Okay. So we have discussed that sparse matrix are two types, either triangular matrix or tri-diagonal matrix. Okay. Sparse matrix either triangular, then tri-diagonal matrix. Now triangular matrix also two type, lower triangular matrix or upper triangular matrix. Okay. Now tri-diagonal matrix means if diagonal elements are non-zero. Okay, then it is called tri-diagonal matrix. You can see this is 0 0 element, this is 0 1, this is okay. So you can see here not only the diagonal, the that means above beside the diagonal elements also non-zero, but most of the diagonal elements are zero, then which is called tri-diagonal matrix. Okay, which is called tri-diagonal matrix. So sparse matrix is given. We need to how to convert this sparse matrix into 2D representation. We have discussed first. Always its content 3 columns, number of rows, columns, and values. Okay. Then first we need to write total number of rows of the array original matrix, total number of columns of the original matrix, and total number of non-zero element of the original matrix. Then we have to check where is the original where is the non-zero element. So 9, 0th row, 4th column element is 9. Okay, 0th row, 4th column element is 9. In this way, we can represent this sparse matrix. And these sparse matrix are two types. One is triangular and another is tri-diagonal. Triangular matrix and triangular matrix. Triangular matrix must be square matrix first, and it is a sparse matrix. So triangular matrix are two types: lower triangular and upper triangular. Lower triangular means most of the upper. When we say lower triangular, always remember opposite. Upper portion is maximum 0. And upper triangular means lower portion are maximum 0. This is called lower triangular and this is upper triangular. Lower triangular means upper portion is 0, maximums are 0. And upper triangular matrix means lower portion maximums are 0. This is called upper triangular or lower triangular matrix. A tri-diagonal matrix means most of the diagonal elements are 0. Okay, or non-zero. Most of the diagonal elements are non-zero, or immediately above or below of the diagonal elements also non-zero. We can say this is called tri-diagonal matrix. But tri-diagonal matrix, there also maximum elements are 0, but only diagonal elements are non-zero, or above or below the diagonal elements also non-zero. Any question? Yes.
Below or above non-zero, or it will be 0.
No, maybe only the diagonal elements are non-zero, others are 0. Then also it's a tri-diagonal matrix. If only suppose this value is not 0, suppose this is 4, suppose 0, 1, 2, 0, 1, 2, 3, 3. It's also a square matrix first. Now 0, 0 element is 4, others are 0. 1, 1 element suppose 3, others are 0. 2, 2 elements suppose 9, others are 0. 3, 3 elements are suppose 7, others are 0. Then it is also a tri-diagonal matrix. Or any of the, or the above or below the tri-diagonal elements also maybe it's non-zero. Maybe suppose this value is 8, then it is also a tri-diagonal matrix. But first condition is always the diagonal elements. What is the diagonal elements? Means I j element of any array, aij element, where I value equals to j value. Then we can say this is diagonal element, this 0, 0, 1, 1, 2, 2, 3, 3. Is it clear?
Yes, sir.
Okay. So this type of questions may come. So now we discussed another topic, which is very important. Please pay some attention here. Linked list. Okay. So first you tell me, what is list? What is list? Anyone?
Sir, which contains items.
Items which contain some items. So collection of elements, okay, which is called list. Now you can say array. With an array, we can also store the elements. But what are the disadvantage of array?
It can store only one type of it.
Okay. Then we can declare array of structure.
So we have to specify how many elements we need or hard coded.
Okay. But dynamically we can allocate. So whatever you are saying, that is also one of the disadvantage of array. Suppose the array is static, most of the array is static. Most they contain similar type of element. But what is the main disadvantage?
Sir, inserting elements in the middle of array takes a lot of time complete.
Okay. First, suppose we have one array. These are the element. Now, I want to delete this element 2. How to delete this element 2? We have already discussed. Tell me how to delete this element 2.
So we will bring 3 to 2 and 7 to 3.
So first we have to shift this element to here. So now this is 3. Now we shift this element here. Now this is 7. What are the total number of bytes required for this array? This is suppose first array, this is second array. What are the total size of this array in bytes?
20.
Sorry?
20.
20 bytes, because total number of element 1, 2, 3, 4, 5. So 5 into 4, 20 bytes. To store one integer value, 4 bytes is required, total 20 bytes. Now tell me, what is after deletion, what is the size of the second array?
20 bytes.
This is ARR 1, this is ARR 2. This is also 20 bytes. Maybe there is no element, but it's occupied, this place also occupies some space. So there is also 20 bytes. This is one of the most disadvantage of array. Suppose dynamically you want to allocate, 10 elements, but you enter only 7 elements. Now already for other 3 elements the space is already occupied, then we cannot delete. Okay, so here we can delete the item, but we cannot delete the occupied memory. Here you can see we delete this item 2, but we cannot delete this occupied memory. So this is one of the disadvantage of an array. Okay, so in this technique, memory can be using linked list. We can allocate or deallocate the memory whenever required. Okay, so that's why comes into this picture linked list. So this is one of the disadvantage. Then insert an element into an array or delete an element into an array, we need to shift either left side or right side, right? If you want to insert an element, between 8 and 9. So we need to shift all the element here. 7 need to shift here, then 3 need to shift here, then 9 need to shift here, then only we can insert an element. So insertion and deletion operations are not that much efficient in array. So that's why because of this problem we will discuss a new data structure which is called linked list. Okay. So first we need to know node. When we are talking about node, node is nothing but pictorially this is node. There is one data part, another one is link part, and this is suppose name is suppose node 1 or node. Okay, suppose this name is node. So here any node contain two things, one is data, another one is link. So data part may contain any type of data. Either data part contain your name, data part contain either your name, you can store only your roll number, you can store name or roll number, you can store only age, you can store name, roll number, age. Okay. So this data part may contain either single integer data, single character data, or single string data, or combination of integer, string, float, whatever data you can store. So node part, this is our data part, and this is link part. There may be more than one data field. Okay, a node may contain more than one data field, but there is either one or two link field. What is the link field? Link field contain the address of the next node. It contain address of the next node. Okay, it may contain the address of the next node. So in this way, it's one node link with the next node. So any node, there is two part. This is the one data part, another one is link part. So data field contain the information and link field point to next node. Okay, so we can write data field, okay, which is nothing but an information. Information may be anything. Only we can store only your name. We can store your name and roll number. So maybe more than one data part. A node may contain more than one data part, but one or two link part. Okay. Now we are talking about only one link part. And link field. Maybe there is another link. Okay, maybe one link or two link. So this link contain the address of the next node. This link contain address of the previous node. So link field what is link field? It stored the address, nothing but it is a pointer. So pointer to next node. Pointer to next node. So it is a pointer variable because it holds the address of the next node. So we know if any variable hold the address, that means it is a pointer. So this is a pointer. This is any link part is a pointer which hold the address of the next node or previous node. Okay, it's a pointer, and data part hold the information. Up to this, any doubt?
Sir, So can you explain this one times more, sir? Node part.
Which one?
Sir, node.
Okay. Node, when we talking about linked list, first we need to know the node. So this is node. This node, there is two part. One is called data part. Another is called link part. Data part contain any type of information. Okay, data field contain any type of information. Any node maybe there is one data field or maybe more than one data field, either one or more than one data field, and at least one link field or more than one link field. Any node may contain at least one data field or at least one link field. At least means maybe more than one data field or maybe one link field is there. So when you're talking about node there is two part. One is data part, another one is link part. Data part, we store the information. Here we can store, suppose your name, your roll number, your age, or we can store whole thing, name, roll number, age, we can store here. So this data part contain either one single information, suppose only age, or we can store any total more than one information, suppose any student name, roll number, age. Okay, up to this clear?
Yes, sir.
And link part contain the address of the any node, either the previous node or next node or previous
But
node.
it compulsory that the data will be in between the link part.
Please repeat again.
So it is compulsory that you have shown us diagrammatically now that the datas are present in between the link. It is compulsory that these are present in between the link.
Data is present between the link, this one.
Yes, sir.
When we're talking about the double link list, then the data must be present within two link part. Or if you
But
want
you
to
have
talk
told
about
that at least one data and at least one link should be present in the node.
yes, at least one data, at least one link must be present in the node.
Okay, sir.
Okay, at least one data field and one link field must be present in the node. When you design a node, then there must be at least one data field and at least one link field. And this link field pointer to the next node or previous node. So it is better to say that link field contain the address of the any node. So when we talking about any point variable or any part contain the address of any node, that means it is nothing but a pointer. Am I right? Suppose if you want to store, suppose you declare int a equals to 10. So when we declare int a equals to 10, then a is a variable. It has some address, suppose 200, and here we store 10. Now we want to declare a variable which hold this address 200. What type of variable we need to declare? If you want to hold the address 200, what type of variable you need to declare?
Pointer.
Okay, so that's why we need to declare a pointer p. So p is a variable. It has own address, suppose 300, and p this pointer variable which holds the address of any integer variable. So if we write p equals to ampersand a, what is the value of p?
200.
200. Similarly, link part also hold the address. It is also a pointer variable which holds the address of the next node or of any node, either the next node or previous node. Is it clear to you?
Sir, if the link is present in between the two data, then means which address it will store?
link is present between two data.
Yes, sir.
But link it cannot be present between two data.
Such that
Link part is always stored the address of any
yes.
node. Okay.
Here you have written a sir pointer to next node or the previous
Yes,
node.
pointer to next node. So this node hold this link part contain the address of the next node. Suppose this is another node. It has own address. So this node address holds by this link node.
So can it be linked data? Then after linked data, can it be means alternative type? Can it be?
Yes, no problem. It is a means conceptual part. How do you represent this one? How do you represent? Suppose you declare a node which hold here which hold the any integer value. Suppose suppose any integer value. Here you want to store suppose 20 or any integer value. This node it has own address, and this node contains the address of the next node. So struct node. Now if we write int suppose value. Now this node address is this. There is another node. This node it has own address suppose 300. Here is the value is suppose 10. Okay. Now this node link part contain the address of the this node suppose 300. Then we established a link this one. Okay. So if we this part hold the address of the next node. So this part hold the address. So that's why we need to declare a pointer variable. Suppose pointer link. Suppose here it's better to declare for understanding. Data part. Okay. And this part hold the address. So that's why it is we declare a pointer variable link. Up to this any question?
No, sir. Sir of identity data type, na, or simply pointer link.
Just say we declare a pointer. Now what is the meaning of this?
Sir, the P is the means data type of int pointer.
Is a pointer which hold
Which holds
the address.
data.
Hello? Yes, integer type of variables data. Address is a pointer variable which hold the address of any integer type of element. Similarly, this link part contain the address of the next node. So what is the data type of this node? This this part contain the address of the next node. What is the address of this? What is the data type of this node? Yes or no?
Yes, yes, sir.
Because we create our own data type, struct node. We create our own data type, struct node. And next node also the data type same. And link part contain the address of the next node. Like p holds the address of the integer value variable. Here link part contain the address of any struct node type, means this node. So this is the data type. Now we can declare so suppose this is a node P and this is node Q. And then we can insert the data link between two nodes we can do. So data type is like this. So it doesn't matter if you write this one here or this one next. This is one of the concept. You can write link here, data part here, no problem. Now is it clear to you?
Yes, sir.
Okay.
And sir, if we have to enter the value, then we have to use struct node dot pointer p is equals to
Yes, yes, we will discuss that one. Okay, how to insert, because this is a
and so
pointer. So for pointer, you need not to use dot operator. What operator you have to use? Using pointer, if you want to insert the value,
arrow operator.
but okay, we'll discuss this one.
Sir, can you give the example of means this you have given that the address will be stored of the next one. No? So can you give the example of the previous one that it will store the previous address?
Yeah, when we discuss about the double linked list, then we can inside. This is also in your syllabus. Okay, no problem. This is called single linked list. Okay, suppose okay. So this node contain the address of the next node. What is the value here?
300.
This node suppose 10, 20, 30, 40 are the value. Data part is 10, here data part is 20, data part 30, data part 40. Here what is the link value here?
400.
What is the value here?
500.
So, and this is called single. Okay. If you want to make it double, so there is two link part. Okay. So here this is left link part is null. Here we insert the value. Okay. This is the address. This part contain the address of the, this is left link. This is called right link. Right link contain the address of the next node. And left link contain address of the previous node. So this is the first node. So previous node is null. So left link is null. What is the value here?
100.
What is the value here?
600.
What is the value here?
900.
What is the value here?
Null.
Okay. So
Yes,
this
sir,
is
got it.
called single linked list. Okay. Single linked list, and this is called double. Okay. And if last node link part contain the address of the first node, suppose this node link part contain address of the first node, then which is called circular. Okay.
Yes, sir. Got
So,
it.
Okay.
circular is only possible
Okay.
in the single linked or it is also possible in the double linked?
Any. It is also possible here. This part contain the address of the first node, and this part contain what is the value here. If we link like this, and this part contain the previous node address. What is the previous node?
600.
Circular. If it is circular, there is no beginning point and ending point, right? If it is circle, can you say which one is beginning point and what is the ending point? So same thing. Okay.
Yes, sir, got it.
Okay. So next time we will discuss elaborately. Roll number 101,
Present, sir.
119,
Present, sir.
148,
Present, sir.
165,
Present, sir.
168, 168 present. 205, 207, 213, 227, 229,
Present, sir.
294, 318,
Present, sir.
320, 353,
Present, sir.
479,
Present, sir.
491,
Present, sir.
567, 575,
Sir, 213, sir.
575, 651,
Present, sir.
660,
Present, sir.
678, 798,
Present, sir.
809,
Present, sir.
811,
Present, sir.
814,
Present, sir.
815,
Present, sir.
817,
Present, sir.
825,
Present, sir.
832, 853,
Present, sir.